Space. The final frontier. These are the voyages of the space probe Mars Climate Orbiter. Its continuing mission: to explore strange new Mars, to seek out new Mars, and new Mars, to boldly go where no one has gone before! Oh. Well, that didn't go well. What happened? We were having a good talk and you just died. You can't do that in the middle of my epic speech. It's rude. Imagine if Star Trek started out that way. The Enterprise just friggin' spontaneously combusts immediately. Would not make for a great episode, I don't think. Unless it's one of those alternate reality episodes. Actually, now that I think about it, I think that there were a few episodes where that basically happened, depending on the series. Anyway, it doesn't really matter. So what the heck is the Mars Climate Orbiter, which I'm just going to call MCO, just because the name is a mouthful otherwise? Well, it was intended to study Mars, but it never really got to do that at all. She was launched and made it to Mars, technically, but once she got there, she just immediately died. Horribly, brutally, so. And obviously, looking into it, they had to figure out why that happened, because they spent a great deal of money trying to make this thing, to put her into space, and it was a complete failure. And what they found is that they are all made of idiocy. All of them. It was a huge embarrassment, to be brutally honest. Obviously, since this is a probe, no one was killed, so we don't have to talk about a loss of life. Which, of course, means I can easily make fun of this. Because, I mean, we're talking about NASA here. These are literally some of the most intelligent people on the planet. They don't hire idiots. How could they make a mistake? Well, I mean, no matter how smart someone is, no one's infallible. Of course, and that's understandable. But when I tell you what the reason was, it's pretty impossible not to make fun of it. The creation of the Mars Climate Orbiter was actually spurred by another loss, the Mars Observer, another space probe, and in this case, that was believed to be due to a rupture in the fuel pressurization tank in the spacecraft's propulsion system. For that design, they had used an engine that was based off of one belonging to an Earth orbital satellite that hadn't actually been designed to lie dormant for the months that was needed to even get to Mars before being fired. It's believed that this likely contributed to that failure. But it's okay! We have the MCO and everything's gonna be great and wonderful and nothing terrible could possibly go wrong. Until it did, but more on that later. NASA was actually looking at this from a cost-cutting perspective. They wanted to study Mars, of course, but, I mean, things were getting expensive, especially since they were working on the ISS about this point, too. They wanted to make a smaller probe that could accomplish what the Mars Observer was meant to do, but at not nearly as expensive and ideally not failing horribly. This new line of spacecrafts should be under 2,200 pounds, 1,000 kilograms, and with very simple but very focused instrumentation. They wanted them to be highly specialized to get key data that NASA was looking for, so they could unlock the secrets of Mars. What are you hiding from us, red planet, and all your redness and sand and hidden water? Where are the green women? We know they're there, don't lie to us. The primary science objectives for the mission consisted of determining the exact distribution of water on Mars, monitor the daily weather and atmospheric conditions of the planet, record changes on the surface due to wind or other atmospheric effects, determining temperature profiles within the atmosphere, monitor the water vapor and dust content of said atmosphere, as well as look for any evidence of past climate changes. The MCO bus measured roughly 2.1 meters, 6 feet 11 inches tall, 1.6 meters, 5 feet 3 inches wide, and 2 meters, 6 feet 7 inches deep. Internally, it was mostly constructed of graphite composite and aluminum honeycomb supports. which is basically the same kind of stuff you'd find in commercial airplanes, to be honest, and perfectly fine for this particular purpose. It was powered by a 3-panel solar array, giving it about 500 watts once it was at Mars, since it's dimmer, since it's further away from the sun. Power from the solar array would be stored in 12-cell, 16-amp-hour nickel-hydrogen batteries, and said power would be used for some key instruments, not just communications with Earth, but also a pressure-modulated infrared radiometer, PMIRR, will be utilized to gather all sorts of information about the red planet. It can map the 3-dimensional and time-varying thermal structure of the atmosphere from the surface to 80 kilometers in altitude. Pretty impressive, as well as a whole bunch of other stuff. But they'd also had a Mars Color Imager, or MARCI. MARCI. The MARCI was a 2-camera imaging system designed to obtain pictures of the surface of Mars. In good conditions, namely no dust storms or anything like that, they get resolutions up to 1 kilometer. The onboard computer used an IBM RAD 6000 processor, and data storage would be on a 128 megabyte random access memory, as well as 18 megabytes of flash memory. But the real question is, can it run Doom, NASA? That's what we all want to know. You gotta explain that part. It's very important. Anyway, everything did come together. Lockheed was even involved in the construction of this, and the MCO would be launched on December 11th, 1998, from NASA's Launch Space Complex 17A at Cape Canaveral Air Station in Florida. They used a Delta II 7425 launch vehicle, an expendable launch system that was designed by McDonnell Douglas. The burn sequence to escape Earth's gravity and start making her way to Mars lasted 42 minutes, and the probe would go on to travel 669 million kilometers, 416 million miles, for 9.5 months to reach Mars. Given the name, the intention here was for her to orbit Mars. That was the entire idea, and locking her into said orbit was, well, all math, really, and it should have been fine. The planned orbital insertion maneuver was to happen on September 23rd, 1999, at 9 o'clock UTC. But, this didn't go according to plan at all. About 4 minutes later, when the aircraft passed behind Mars, NASA lost all contact with her and was never able to regain it. For one thing, this was already kind of concerning that she did this because, she wasn't supposed to go behind Mars that quickly. It was 49 seconds earlier than their math had shown, which is a pretty major discrepancy when conducting this kind of maneuver. Also, in the fact that they couldn't contact her at all. She wouldn't answer them. She was just gone. And the mission was a failure. NASA was kind of left scratching their heads over this. Well, they got together a mishap investigation board. And on November 10th, 1999, they released their Phase 1 report, detailing the suspected issues involved with how they lost this spacecraft. Because, okay, the MCO was a cheaper type of spacecraft, but she was still really freaking expensive. The cost of the mission was about, $327.6 million. So everyone was kind of trying to figure out why their money had basically exploded. To begin with, on September 8th, 1999, Trajectory Correction Maneuver 4, TCM-4, had been computed, and the spacecraft did execute that on September 15th. That was meant to place her at an optimal position for an orbital insertion maneuver that would bring her around Mars at an altitude of 226 kilometers or 140 miles. But already there was something wrong. The navigation team reported that it appeared the insertion altitude would be much lower than they had planned, roughly 150 to 170 kilometers. 24 hours prior to orbital insertion, calculations placed her at a horrifying 110 kilometers, just 68 miles. And mind you, 80 kilometers, 50 miles, was the minimum that she was thought to be capable of surviving during this particular maneuver. Technically, she should have still been in the safety zone, but they already kind of knew something screwy was happening, because they couldn't be messing up their math this bad, okay? Something weird was going on, but there wasn't really much they could do about it. I mean, she was already hurtling through space. What are you going to do there? You don't even know exactly why any of this is happening, and you don't have time to fix it. You either execute the maneuver or you don't, but if you don't, she's just gonna hurtle off into forever, like eternally, like she's just gone. So they kind of had no choice. During the insertion maneuver, she was supposed to skim through Mars's upper atmosphere and use that to brake for a few weeks to a stable orbiting speed. But the failure likely happened about here. Post-failure calculations showed that her trajectory would have put her within 57 kilometers, just 35 miles, from the surface of Mars. At that altitude, at the speed she was going, one of two things was going to happen. Either she would have been bounced off the atmosphere, or she just simply exploded, basically. Disintegrated was probably a better term, but either way she was destroyed. But regardless, they knew the how, but they still didn't know why. Because I've thrown a bunch of numbers at you, but none of them seem to add up. Because they keep calculating all this, yet the numbers are lower than they should be. Consistently so, and keep getting much lower than they should be until we have a critical mission failure. So what the heck? Well, remember how I said Lockheed was involved here? Right, so one piece of ground software that was supplied by Lockheed Martin produced results in United States customary units, otherwise generally referred to by most people as imperial measurements, like true red-blooded Americans. But the problem is that it had a software interface specification, or SIS, which would have used SI units, generally referred to as the metric system. NASA had a second piece of ground software that expected these units to be in SI, and took them as if they were SI. They were not. They were using imperial measurements without converting them to metric, just taking them as if they were metric, and I don't think I need to explain to most of you why that's a pretty major problem. The software that calculated the total impulse produced by thruster firings produced results in pound force seconds. The trajectory calculation software used those results, but as if they were Newton seconds. They were off by a factor of 4.45. It was ridiculous, but Lockheed wasn't actually blamed. Even NASA didn't blame them. And the reason for this is that, frankly, NASA should have double-checked all this. They should have known something was wrong. Remember, they are staffed by some of the smartest people on the planet. Their staff includes literal rocket scientists, and none of them noticed that one of the systems was using Imperial, and they weren't converting it to the metric they were supposed to be using. No one checked that. Various officials at NASA took responsibility, explaining that they should have taken the appropriate checks, as well as tests that would have easily caught this basic math discrepancy. Part of the reason NASA took responsibility is that they actually did catch it. Two of the mission navigators noticed something was off, but their concerns were dismissed because, and I quote, "they did not follow the rules about filling out the form to document their concerns." Really? Really? It was bureaucracy? That was the problem? You didn't do the proper paperwork to point out that, hey guys, we're about to blow up millions of dollars in the Martian atmosphere if we don't convert the friggin' units properly. Are you guys kidding me? And the loss of the MCO was just 2.5 months before the loss of another Martian mission, the Mars Polar Lander. Though in that case, it's believed that it was caused by a premature termination of the engine firing prior to the lander touching the surface, but regardless, this was all super embarrassing for NASA. Because, what are you guys doing? You're supposed to be really good at this! This is like your whole job, and it's just one planet, like come on, we went to the moon, okay? We can go to Mars if you just try harder. Well, admittedly, part of the reevaluation showed that it might have actually been down to the cost. Remember, part of the point of this mission, and the Mars Polar Lander too, was to do this for the minimum amount of money. But as it turns out, you probably shouldn't actually do that, because the effort to save money was starting to become the whole focus, and the result was that the missions were just kind of sloppily put together. If they had had a bigger budget to work with, they would have been able to take more time with it, and easily identify the actual problems prior to launch, which is exactly when you want to do it. You don't want to find problems after you launch. That's bad. But in any event, the mission was a complete failure. with the Mars Climate Orbiter either destroyed or, she could still be out there. Because if she bounced off the atmosphere, her remains could still be hurtling through space somewhere. Maybe she's just hanging out, vibing, screaming into the void about how you idiots can't do conversions right. And I'm sure I'm going to get plenty of comments about, well, maybe if the United States would adopt the metric system, they really should. Never! This is America, you fools! We will stand with our feet and our inches and our miles for eternity! Freedom! You'll never take it away from us! Never! Till next time, this is Darkness, and I bid you all a fond farewell.